uniform motion problems today, you guys, that we're starting with are the easy ones where they're equal distances. So you might want to write that down. We're doing uniform motion problems today, and they're all going to be equal distances. That's nice when they're equal distances, okay? And then we're going to go over similar triangles, which we already kind of did, but we'll talk about that again. All right. So Elvira made the trip on Tuesday, and David made the same trip on Wednesday. So because of that sentence, we made the trip, and then we made the same trip. So because of that, we have equal distances, all right? So the first thing we're going to start with is that the distance that Elvira went is equal to the distance that David went. Then it says Elvira traveled at 14 miles per hour, so that is a rate. Miles per hour is a rate. David traveled at 21 miles per hour, that's a rate. And so his time was 3 hours less than Elvira's time. How far did they travel? All right, so we always replace distance with what? Rate times time, okay? So distance is equal to rate times time. And so I have the e's on one side. Over here, David, we're going to do rate David time David. Okay, rate times time, rate times time. And then we just plug in all this really fun stuff. So we've got Elvira traveled at 14 miles per hour. So that would be rate Elvira. So I'm going to plug a 14 in for rate Elvira. David traveled at 21 miles per hour. So David's rate is 21. We're going to set these equal. And then we have the time formula. So his time was, so David's time, and if you want to do this off to the side, you can. David's time was 3 hours less than Elvira's time. So that means that we just subtract 3 from Elvira's time, and they're equal. So I'm going to replace TD with Elvira's time minus 3. And then I keep this TE in the equation. So we always should get down to one variable which we can solve for. And so let's go ahead and solve for TE. So I have 14 TE. We're going to distribute the 21 here. So that's 21 TE minus, 63. That should be a minus sign. Hold on. Okay. All right, I'm going to subtract 21E TE from both sides. So that's negative 7. Don't lose your negative 63 here. Divide both sides by negative 7 and we get 9. All right, if you got a negative number, do you know you messed up? Yes. Even if you get a decimal, you probably messed up on these. They usually turn out nice. All right, so go back, see if you can correct it. And then we need units. So this is time Elvira. So if it's time, this problem is talking about hours. So 9 hours is how long it took Elvira. But what did they ask? All right, that's nice that we found the time. But what did the problem ask? How far did they travel? Well, they traveled the same. So you can come back here or here and figure out how far they traveled, right? I'm going to stick with this side because we found the 9. So I could plug in the 9 hours for the time of Elvira. And what is 14 times 9, you guys? 84. So that means this total distance here is 84 miles. If we wanted to check it on the other side, we could. We could plug in a 9 right here, which means the time, was that wrong? Thanks, Leo. All right, 126. Thanks. We could also check that, right? 9 minus 3 is 6. So the time that David traveled was 6, and his rate was 21. And we could multiply those together, and we also got 126, right? So their distances are equal. And we got the problem. All right. Briar Rabbit hopped off towards the briar patch at 10 kilometers per hour at 10 a.m. At noon, Briar Wolf began the chase from the same starting point. If he caught Briar Rabbit at 2 p.m., how fast did he run? All right, so one person started after the other one, but if somebody's chasing somebody and you started from the same point, right, then you're going equal distances because it's when somebody caught somebody. So they're going to still be going the same distance. So the distance of the rabbit is equal to the distance of the wolf. All right, so rate rabbit times time rabbit equals rate wolf times time wolf. Equal distances. All right, so let's figure out what we can plug in. Anybody have something we could plug in on this problem? Ethan? Good. So the rabbit hopped off at 10 kilometers per hour. So the rate of the rabbit is 10. So I'm going to plug that in here. Okay, and now we've got some times that we're going to have to think about, right? So Briar Rabbit hopped off. He left at 10 a.m. All right? And the other guy left at noon, and they caught each other at 2 p.m. So we can figure out both of their times actually pretty easily here, right? So the rabbit left at 10 a.m. and was caught at 2 p.m. So how many hours was the rabbit traveling for? What's 10 a.m. to 2 p.m., you guys? 4 hours. So the time of the rabbit was 4 hours, okay? We don't know the rate of the wolf. In fact, that's what it's asking for. How fast did the wolf run? So rate wolf. But we do know the time of the wolf, right? The wolf started at noon and caught him at 2. So what's the time of the wolf? 2. Bless you. All right, and then we can solve. So this would be 40, and I like to put the 2 in the front, 2RW, divide both sides by 2 here. And the rate of the wolf is 20. We do need units. Is this one miles per hour? No, this one was kilometers per hour. Okay, so the wolf went 20 kilometers per hour. All right, go ahead and draw that proportion. All right, so just remember we match up sides by their angles across from them. So the 1 goes across here and here, which means the 9 and the y. I don't know why that has a period. The 9 and the y are across from each other, right? And then we've got the 6 and the 5 across from each other. And the one that doesn't have an angle also matches up, so I'll circle those in green. So across from the no angle is x, and across from the no angle is 7. All right, so match them up that way. We could write one proportion here, which I kind of learned the other day. This was kind of interesting. Let's try that this way. We're going to actually make a little mini ratio box. And what I'm going to do is go around the circle. So across from the 1 is a 9, okay? Across from the 2 is a 6. And across from the no angle is a 7. So then I have to go in the same order here. So across from the 1 is what variable, you guys? Y. And across from the 2 hash is what variable? 5. And across from the no angle is x. So if you want to kind of set it up like that and then cross multiply, you can. What you have to use to solve for both is this fraction that has both the numbers we actually know the values on. So I'm going to cross multiply here to find y. So 9 times 5 right here equals 6 times y. So I'm going to cross cancel this, reduces to 3 and 2. So I get 15 halves for y. Okay, and then I'm going to cross multiply on this side so I can find the x. So 6 times x equals 5 times 7. And divide by 6. I don't think either of those reduce, so we get 35 over 6, which does not reduce. All right. Questions on that? Everybody